Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hi, welcome to the Pytorch tutorial series. Today we'll start convolutional neural network. Over the course of 3 videos, we'll try to explain and explore the convolutional neural network in Pytorch. Today's video is about the concepts of convolutional neural network. In the next video, we shall see how convolutional neural network is implemented in Pytorch. We'll get used to the functions and methods, and in the third video, we shall train a convolutional neural network model on a real dataset and see how it performs. So what is convolutional neural network? First thing you have to understand is convolution. Convolution is a concept of mathematics. As we all know that convolution in mathematics is almost like a multiplication of two functions, but it's slightly different from the concept of neural network perspective. All we need to know for now is convolution is superimposing two functions. So why do we use CNN or convolutional neural network? The answer is computer vision. As human beings, we can see things and detect objects and count the number of objects and identify objects in an image. But how does computer see things? That is the study of computer vision. And after the invention of CNN in 2012, computer vision has been gifted with a very huge amount of accuracy using CNN. So let's consider images of cats and see whether as human being we can identify those. So these are the 6 images of cats, and they are all different from one another from the perspective of breed, color, background, and also you can notice that the last image is a half face of a cat. So as human beings though, we can all identify that all these images belong to a cat. But for a computer, it's really hard to understand since the colors are different, the backgrounds are different, the shapes, sizes, the angle of photograph, everything is different. So how can a computer identify a cat in an image or count the number of cats in an image? To do that, it has to identify a cat first. So the solution is convolutional neural network. How do we build a convolutional neural network? The answer is very simple. First, take the image. Then you have to build a convolution layer. You have to build pooling layer. Now, we might repeat these 2 layers many times. In the end, we usually have only one fully connected layer, that is multi-layer perceptron that we saw in the previous videos. And in the last stage of the multi-layer perceptron, we will have a classification function. If it's binary, we can use logistic. If it's more than 2 or 3 classes, we can use softmax function instead of a simple sigmoid function to build our last layers of CNN. So as I mentioned, there are 4 steps to build a CNN: a convolutional layer, a pooling layer, a fully connected layer, and an n-nary, as in if 2 it's binary, if 3 it's trinary, and so on, an n-nary classification layer. So what do we do when we train a model on using CNN? So there are three things to learn from an image. We have to learn the edges, we have to learn the colors if it's a color image, as in we have to understand the R channel, the B channel, and the G channel of the image, and we have to learn the curves in the objects of the image so that we can identify those objects anywhere and in different positions in images. All in all, we call this feature learning. Let's take the image of a cat and we can break it down to a collection of small boxes. We can call each of them 1 pixel. So there are 10 boxes horizontally or 10 columns and 8 rows. So it's a 8 by 10 image. Let's consider that one. And we have a 3 by 3 filter. And we will now build the convolution layer. So how do we do it? We take the image and we take the filter and we keep on scanning the image using that filter. So first we take first 9 boxes, then we keep moving and scanning the whole image. And once we do that, we learn features. This way, we can make as many filters as we want. We can keep the dimension of filter anything, but the most important thing is to learn the features from an image. So just to give you an idea how convolution is done in CNN, we will not go into much deeper mathematics. We just keep things very simple and let's discuss some very basic mathematical stuff. So let's say the pixel intensities in the first 9 pixels are as follows: 200, 200, 100, 200, 200, 150, 250, 200, and 150. And just like that, every box has certain intensities of the pixel, and we have this filter 1 0 minus 1 0 0 0 1 0 minus 1. Now we superimpose the filter on top of the image. Like I said before, you need to understand that convolution is the superimposition of 2 functions. So one function is this image, other function is the filter, and when we superimpose those two, we basically multiply them and eventually we have something like this. If we multiply these two, it's just an element-wise multiplication. So 200 multiplied by 1 is 200, 200 multiplied by 0 is 0, 100 multiplied by minus 1 is minus 100, and so on. And like that, you get this output. After this, you need to build a pooling layer. So pooling layer can be of 2 types. First type is max pooling. So max pooling is basically max of this whole matrix. So the maximum value is 250. Other kind of pooling is mean pooling. It's basically the mean of all the elements of this matrix, which is this. So although there are other kinds of pooling as well, but like I said, we will keep things very simple here. And this is how you build a pooling layer. And we repeat this step many times and we keep the number of filters as many as we want, but you need to be economic with the resources. So you don't have unlimited resources, so you have to be careful about that too. That's how we build the convolutional and pooling layers in CNN. And after that, we feed everything into an MLP, which is then passed into an either sigmoid activation layer or softmax activation layer, which gives us probabilities of what the image belong to. For example, here there is a probability for bird, probability for sunset, probability of dog, probability of cat. In this case, of course, this probability should be highest if the model is correct. Thanks for watching.